The Big Bang model of the universe. The Big Bang was an expansion of the universe in every direction at every point. Rather than a big explosion, it was more like a rapid inflation. Hubble showed that light from distant galaxies was redshifted, and so these galaxies were moving away from us. This showed the universe was expanding, so we can reverse this logic to argue that at some moment everything in the universe was very close together at one very hot, very dense point. So here's a quick timeline of what scientists think may have happened. 10 to the minus 43 seconds after the Big Bang, gravity separates from other fundamental forces. 10 to the minus 36 seconds after, the strong nuclear force separates from other fundamental forces. 10 to the minus 32 seconds after, the universe rapidly expands and is now a medley of electrons, quarks, and other particles. 10 to the minus 11 seconds after, the electromagnetic and weak forces separate and quarks start to gain mass. 10 to the minus 6 seconds after, the universe cools slightly due to the expansion, and quarks form protons and neutrons. 1 second after, protons and neutrons combine to form nuclei, but conditions are still too hot for atoms to form. 400,000 years after, atoms are formed and light begins to shine. 1 billion years after, clouds of hydrogen and helium gather due to gravity, forming the first stars and galaxies. 13.7 billion years after, the galaxies are formed via gravity, and large enough stars release heavy elements into the universe when they die, which forms planets. So how do we know all of this information? Well, scientists can actually see light from the Big Bang. Remember how I said that light from distant galaxies was being redshifted as they move further away from us? Well, light from the Big Bang has also been redshifted as the universe expanded, and it has been redshifted so much that now this radiation has been stretched into microwave radiation. So, scientists analysed this cosmic microwave background to find out what the conditions in the early universe were like, and one thing's for sure, the conditions were hot, very hot. How can we tell? Well, when you measure the intensity of the different wavelengths of microwave radiation in the cosmic microwave background and plot these on a graph, you get a bell shape known as a black body curve. This curve can be plotted for really hot objects, most notably stars. So the fact that this cosmic microwave background had this precise curve was pretty good evidence to suggest that the early universe was very hot.